let's go back to today's notes. Now we're going to use those properties and proofs here today. Okay, use the properties and proofs. I'm trying to warn everybody. If you don't want to take my advice, that's fine. Tomorrow and Wednesday, we're going to do the rest of the quadrilaterals, which means bam, 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 properties everywhere. So I recommend you get your parallelogram, rectangle, rhombus properties written down somewhere, Quizlet, index cards. If not, okay. All right, it's going to be an avalanche the next 2 days. Let's roll with this. This bad boy is a rectangle. You got M's the midpoint, and we're trying to show ZMY is isosceles. So first question I have to somebody is, how do you know a triangle is isosceles? All right, if we're going to prove it's isosceles, how are you going to know it's isosceles before we get there? Let's start us off. 1, 2, Finley, how do I know a triangle is isosceles? Two sides are angles. Good. In this one, we'll do the sides. All right, we'll do the sides. Somehow I need to get ZM and MY. That's not true. I'm just showing you what I need right now. As a group, we need to get MZ and MY congruent. All right, this is like a definite broken record, repeating myself every time. Let's see if we're at this point. Those two sides are not going to be congruent unless what's congruent first? Those sides aren't going to be congruent unless I prove what congruent first? The triangles, right? CPCTC. So that is where I'm going to need your help first, is to prove triangle WZM congruent to triangle MXY. So that's where we're going to start this proof. Get me those triangles congruent somehow. And I'm just going to throw it out to anybody right now. You either can use properties of a rectangle to get sides or angles, or you can use M as a midpoint, right? Because right now, I don't have any S's or A's in parentheses. You are on the hook for all 3 pairs of sides or angles right now. You are on the hook for that. I'm hoping you can at least find 2, maybe all of them here, hopefully. All right, you can start anywhere you want, whether it be properties of a rectangle or the midpoint given. Give me something true about the sides or angles right now. Let's roll. Stellan?
MYZ and MXY are right angles.
Which ones again?
MYZ.
MYZ?
Yeah.
This angle?
No. MW.
MWZ, and what's the other right angle I'm going to need?
MXY.
Yep, so I got right angles here. I know what a rectangle is, right? Has all right angles. So first thing I'm going to say, angle W and angle X are right angles. I didn't need to do this first, but that's what was given to me. Usually now we know in the reasons column what? Perpendicular lines form right angles. Definition of perpendicular. Well, I don't have perpendicular lines here. I have a rectangle instead. So in the reasons, now we'll write, just like we've done for parallelograms, rectangle implies you write the property. All right, I can't write perpendicular lines form right. I don't have them. But rectangle implies all right angles. And you guys know the drill. As soon as I say I have right angles, right after that, I got to tell you what? They're congruent. Things don't change in here just because the unit number changes. Angle W congruent to angle X. All right angles congruent. And now I can put an A in parentheses if you do that stuff. Now I have a pair of angles. 1 down, 2 to go. 1 down, 2 to go. All right, what else do you can still use rectangle properties. We still got that midpoint hanging out there. What else is true about my sides or angles? Whoo, Tess? There you go, another rectangle property. It is still a parallelogram, right? So opposite sides congruent, perfect. WZ congruent to XY. Now let's talk quickly. Am I wrong if I start this off with parallelogram implies? A rectangle is a parallelogram. So you can start this off with parallelogram implies or rectangle implies. Doesn't matter. All right, it's a parallelogram property too. I'll stick with rectangle. Rectangle implies all, well, not all sides, sorry, opposite sides congruent. But if you plugged in parallelogram, that's fine. But I can't plug in parallelogram for reason number 2. That's only for a rectangle, right? I can't do parallelogram there. All right, there's a pair of sides. 1 more pair to go. Remember, we haven't even sniffed that midpoint yet, so probably that's where the 3rd pair is going to come from. But I'll leave that up to you. Where's my 3rd pair up here? 3rd pair, Shar, sorry. Come on now. There we go. Yep. Had me nervous there for a second. WMMX. WM congruent to MX. Definition of a midpoint. Been a while since we used that. That's a side. And I think we have enough now, don't we? I'm just going to need a reason from somebody. So step 6, tell me those triangles are congruent. Triangle WMZ is congruent to triangle XMY. And reason, there's only one it could be. Only one it could be here. Lily, good deal. So I should have 2 more steps. There's a reason why we needed the triangles congruent was to get those sides in the isosceles triangle congruent, right? So MZ and MY. Now if the triangles are congruent, so are MZ and MY. And what's my reason there? I know we went over it, but just to make sure we're solid. Bailey?
CPC.
Yep. Once the triangles are congruent, so are all the corresponding parts. And now this bad boy's isosceles, huh? Now that we got MZ and MY, it's isosceles. Triangle. And just tell me why in your own words it's isosceles. How do I know this is isosceles right now? In your own words, I'll write something down. Lily, back to you.
There's 2 congruent.
Okay. Yeah. 2 congruent sides. We can put implies isosceles triangle. Damn. So that was using some of your rectangle properties to figure out the proof. Using some of your rectangle properties. I'm going to skip over the second one. I want to do all the statement reasons ones before I introduce this new type of proof today. All right, so go to number 3. Now I'll give you it's a rhombus, and let's do a little work. All right, and number 3, now you know it's a rhombus. So switch your mind to the rhombus properties and look over this proof quick, and then we'll start talking. All right, so everyone sees where the rhombus is and see where the congruent angles are. FAB, follow them, FAB, it's that whole angle along with DCB, that whole angle. All right, look at the proof statement. Oh, here we go, ready. FE and DE aren't going to be congruent unless the triangles are. Yes, got to have the triangles congruent first before you say FE and DE. So fine, here are the 2 triangles, FEA and EDC. Let's get these 2 congruent together. Oh, let's see if we're at this point in the year 2 here. This pair of angles they provided me in the given, can I put an A in parentheses? Are those angles I can use to say those triangles are congruent? No, great job. Great job. They are not angles in those, so I'm not going to put an A, which means you have 3 that you're on the hook for right now. Whew. All right, let's do it. Remember, that's a rhombus. That's a rhombus. Do remember our properties here. Anything I can use here, or anything you see on your own. It doesn't necessarily have to be a rhombus property. Anything you see on your own between those 2 triangles. All right, here we go. Come on, dig deep. Cormac, anything?
AE equals EC.
Oh, a little rhombus property. Yep. AE is congruent to EC. Yeah. Rhombus, because this only happens in a rhombus, not a parallelogram, implies what property did Cormac just use there to say those 2 sides were equal? What property is he using? Drew? All sides congruent. I don't need all sides. I just needed those 2. All right, I didn't need to put all 4 there. I just needed those 2 in the triangle. All sides congruent. Love it. So there's a pair of sides. you should at least get another pair here. I'll understand if you're confused with the third pair, but we should at least get another pair of either angles or sides here. We should at least get another pair here for me. Look at your diagram. We should at least get another pair here. And I don't want to give any hints either. Jonathan, anything? And it has nothing to do with the rhombus. Nothing to do with the rhombus. It just says, look at the diagram and see these. Angle FEA. And anything else? How about DEC? What type of angles have we been working on those since Unit 2 here? Yeah, what do you know about them? Okay, that's the ones I'm looking for there. Gotta spot them. Gotta spot them. FEA, congruent to angle DEC. Vertical angles are congruent. There's an A for everybody. Which means we have one more pair to go. And what have we not even talked about yet? It's got to have something to do with what? We haven't even talked about it yet. Yeah, one of the like those two angles being equal, FAB and DCB. It's got to be something with those. Something involving those. I'm giving it to you for a reason, not to forget about them and overlook them. Use them. All right, we have one more pair left, and we have not even sniffed those being congruent. So it's got to be something involved with those. That gets me another pair of angles or sides. And I don't want to give it away. I'm not going to call on anybody either, but if anybody sees it, you can let me know. That'd be great. Bailey, go ahead. Nice and slow for everybody.
EAB and ECB are congruent.
Okay, hold on. Here's what Bailey just told us. Look in the rhombus, please. Look in this rhombus. That's also a parallelogram. Aren't opposite angles congruent? And then what are we going to do with the given angles and those opposite angles? Subtract them. Okay, so we're going to subtract to get a pair of angles inside the triangles. All right, all good? Because I'm just going to go right now. All right, first thing you got to tell me, those opposite angles are congruent. So good job, Bailey. Angle EAB is congruent to angle ECB. You can write rhombus. You can write parallelogram because it's a property of both, right? It's a property of both. Rhombus implies opposite angles congruent. Then do your subtraction substitution. Go ahead. The bigger angles in the givens. That's an E. Substitution to say angle FAE congruent to angle DCE. And there is my third pair, which ends up being a pair of angles. So two more steps. The triangles are congruent and then CPCTC, but I need to know from somebody because up here I have two angles and a side. So it could be angle, angle, side or angle, side, angle. You guys got to figure out where that side is, in between or no. So triangle FAE is congruent to triangle DCE. What are you going with here? What method? Side in between or not? What method are we going with here? Going deep, Brendan? Good deal. Side is in between. And then finish that up with the sides are congruent by CPCTC, FEDE. One thing I can promise you is I will never have you prove a rectangle or a rhombus in a statement's reasons proof. All right, if we're going to do a statement's reasons, it's always going to be given a rectangle and a rhombus, probably prove some triangles congruent. All right, I will never ask you to prove it's a rectangle or a rhombus in the statement's reasons. Anything here before I introduce a new type of proof here today? I don't know, maybe some of you will like it better than this, probably not, but we'll see. Questions, comments? All right, let's go back to number 2. Now, I want to introduce a new type of proof where your diagram is on the graph. All right, the diagram will be on a little piece of graph paper. These, just so you know, so I don't have to call it proofs on a graph, these are referred to as coordinate proofs. The reason it's coordinate, because it's on the coordinate grid. Okay, these are coordinate proofs where your diagram is on the graph instead of just drawn out for you. So before I talk, go ahead, get that quadrilateral PQRS down for me. Okay, have it graphed here, ready to go. And you guys can keep reading. We got to show this as a rectangle. When we do these coordinate proofs going forward, there's no statements reasons. All right, there's no 2 columns, so we're going to organize it a different way. But you'll start to see now why this is a little bit different. Now we're involving numbers. Okay, never before have we involved numbers in our statements reasons. So because we're involving numbers, you're going to need 2 formulas for these coordinate proofs. 2 formulas. And these are 2 formulas you're familiar with. It's not anything new. First formula we're going to need, slope formula. Okay, slopes. And you'll see right away why we may need slope formula. And when I say slope, I'm not talking about y2 minus y1 over x2. I don't want you to do that math. I just want you to count. Nice and easy. So instead, when we use slope, we're going to use rise over run. All right, we're just going to use rise over run. Count how many you go up, count how many you go over right on the graph. The second formula we're going to need, and I know I'm sure this will make everybody happy, going to need the distance formula. Okay, going to need the distance formula. So review that again. Big square root. Underneath my square root, x2 minus x1 all squared, and then y2 minus y1 all squared. I'm not saying you're going to need both in every coordinate proof. We may just use one and not use the other. But as we go through all these coordinate proofs, you're going to need them. All right. Again, we may not use both in a proof. We may only use one. Okay, so hopefully I'll do my best here to show you why we need those 2. So let's go back to the one we're asked to do. Show it's a rectangle. There's only one way we're going to do it in here. I have 3 ways listed here. There's only one way, and here it is. Reason 3. We're going to show it's got 4 right angles. All right, we're going to show it's got 4 right angles. Because that's what a rectangle is, 4 right angles. Don't do it on yours. So here's what you need to show me. Why is Q a right angle? Why is R a right angle? Why is S and why is P a right angle? That's what you're going to need to show me. So let's back up. How are right angles formed? If 2 lines are perpendicular, right? Everyone agrees there. All right, so we got to keep going. All right, right angles are formed if 2 lines are perpendicular. That's why we need this formula. Slope. Anybody remember if two lines are perpendicular, what you know about their slopes? No, that's parallel. If they're good, you're going to need that though. If two lines have the same slope, they're parallel. But if they have this types of slopes, they are perpendicular. Negative reciprocals, correct. So what you're going to show me right now is all these slopes are negative reciprocals of each other. That means they're perpendicular. Here's how we set up these coordinate proofs. Step 1, you choose the formula you want to use. What did we just say? We need what formula? Slope, right? So the first thing, you're going to pick a side. You're going to pick one of this. Let's pick QR. Anybody remember the letter for slope? So I can just start abbreviating. M, right? So M, and I'm going to put a little QR next to it that says we're going to find the slope of QR. Equals. You do rise over run now on the graph. You count from R to Q up and over how many? This is why I like this method a lot better than trying to do subtracting of Y's and X's. Up and over how many? What do you guys have? Up and over how many? Up 2 over? Or down 2, it doesn't matter. You tell me. 2 over 3, right? Either way? Okay. 2 over 3, but I can't accept that because you guys have to notice, look where QR is going. Downhill. I should have put what here? This is a negative 2/3. Good. So negative 2/3. Keep finding the slopes so you guys can see the relationship. All right, let's go to RS now. Slope of RS. Do a little rise over run for me again. And we'll try to put all this together. What do you have here? Up and over how many? 6 and 4, right? Yep. Positive or negative? Look at the line. RS. Going left to right, going uphill. It's going uphill, so we keep it positive. Here's the problem, though, and here's where I need a favor from you. Look, I got 2 and 3, and I got 6 and 4. They don't look like they're the same. Negative reciprocals, there's all different numbers. I need you to reduce if possible. So if you don't know how to reduce 6 over 4, you take the darn calculator and you plug in 6 over 4 and hit enter, and it will reduce it for you. No questions asked. All right, so if you can't reduce 6 over 4 on your own, you do 6 over 4 in your calculator, hit enter, and it'll tell you 3 over 2. Oh, okay. Okay, now I'm starting to see a little relationship here. Negative 2/3, 3/2, little flip and change, right? We're not done, though. We got 2 more. Let's go PS. PS. And again, what do you notice for PS? Negative 2/3 for your slope. And darn it, it should. It should. We're telling you already this is a rectangle. You got to show me why. So if you get negative 2 over 4, either A, you counted wrong, or B, you graphed a point wrong. These should all come out like this. Right? They should. It is a rectangle, guys. You just got to show me why. And then one more slope. QP. That's the only one we haven't done. And does that come out to be 6 over 4 again? Oh, okay, yeah, which we know reduces down to 3/2. Step 1, show me a formula. Might be distance, depending on the problem. So show me the formula. Keep it organized now. Step 2, what did you just learn in step 1? You did all these slopes. What did you just learn now? Well, let's take a look at QR and RS. QR, negative 2/3. RS, positive 3/2. Tell me a symbol to put between those now, because those slopes came out like that. QR and RS, negative 2/3 and 3/2. What do I now know for those 2 lines? QR, RS. Let's go here. Lauren? Darn right they are. They're perpendicular. Those aren't the only 2. You write everything. Those aren't the only two that are perpendicular. Name another pair that have to be perpendicular because their slopes are negative reciprocals up here. Give me another pair. Keep feeding here. Cormac.
PS and QP.
PS, QP. Yep. PS, QP are perpendicular. Oh, there's more up here. There's more negative reciprocals up here I haven't put together. Come on, keep going. I need them all. Need them all. Give me another pair here. Woo. Henry.
PQ and QR.
PQ. QR. And I think there's one more pair. There should be 4 total. There's one I'm missing. What's my missing pair up here? Take your time. What do we got, Bryson?
RS and PS.
RS and PS. Yep. There you go. Those are all perpendicular, but you got to tell me why now. How do you know they're all perpendicular? Because, how did we know? Slopes are, there you go. Slopes are negative reciprocals. So step 1, you show me the formulas. Step 2, what the heck did you just learn by doing all that? Could I have also said QR and PS are parallel because they have the same slope? Yep, but I just don't need it in this proof. All right, I just don't need it. I need the perpendicular lines. Why? Now start thinking like you're doing statements reasons. What do we usually say after lines are perpendicular? What do I have now? I have right angles. Correct. So here we go. Angle Q, comma, angle R, comma, angle S, comma, and angle PR, right angles. Because, and again, I don't want to hear because slopes are negative reciprocals. I've used that. How do we know they're right angles? Just like we're writing it in the statements reasons column, right? Why are they right angles, Bailey?
Perpendicular lines form right.
Because perpendicular lines form right angles. All I'm asking out of these, please be neat and organized. Don't have step 1 in one corner, step 2 in the middle, step 3 in another corner of your paper. Keep this nice and organized. And then let's finish this now. They're all right angles, so we know this is a rectangle. Q, P, Q, R, S is a rectangle. Because, in your own words, how do we know it's a rectangle? Nothing about the slopes. Nope. Use what we just wrote down. How do I know PQRS is a rectangle now? Let's finish this in your own words, Selen. Why? What's it have?
Has all right angles.
Done. Because it has all right angles. No other quadrilateral has 4 right angles. It's got to be a rectangle. Can't be any others. Anything you want to throw out? We got one more. I know the one doesn't make you great. Probably makes you uncomfortable and awkward. We're good here. All right. Last one then. Number 4. Now show me it's a rhombus. So go ahead and graph your quadrilateral. All right, we got to have a graph. Now we got to show it's a rhombus. like the rectangle, there's only one way I'm going to have you do it. I know I have 4 listed up here, but there's only one way I'm going to have you show it's a rhombus, and that is nice and easy. Show it's got 4 congruent sides. So number 1 up here. Way number 1, that's the only way we're going to do it in here. If it's a rectangle, you show it has 4 right angles. If it's a rhombus, you show it's got 4 congruent sides. So I don't think slope is useful here. I'm going to need what formula to show it's got congruent sides? Distance, correct. All right, so in step 1, that's what you guys are going to show me. The distance of all 4 sides. So I'll start it off with you. We can do the distance of, I'll start with DC. So DC is equal to big square root. Underneath, I show the x's being subtracted and the y's. So x's are what? 9 and 6. 9 minus 6 all squared plus the y subtracted. 1 minus 5 all squared. And I don't feel bad that you have to do all 4 of them because that's it right here. After this, you literally just type it in your calculator and it'll do all the work for you. All right, so you don't even have to do any of the algebra inside the radical. We just got to make sure we type it in correctly under 1 square root. Don't come out of it. And we're getting the length of DC hopefully to be 5. All right, here we go. Let's keep plugging along here. Where do I want to go now? I did DC. I guess I'll do AD next. And this will be the last one I do with you. Let's see. AD, 2 minus 6 for the x's. The y's are 2 minus 5. You know what you should get, right? You know what you should get. Just hope your calculator gives it back to you. If it doesn't, we did something wrong. Because all these sides should come out to be the same. And you guys are finding out it is 5 again? Yep. So I will let you go and find the rest of the 2 sides, and then we'll write this proof together at the end to finish it up. I do need to see work too. Some of you slicksters here, it should be 5, so you just might write the number 5 and that's it. I need to see what you're plugging into the distance formula at least. All set with all 5s? All right, remember now, step 1 is always the formulas. Step 2, what did we just learn? What did we just learn here? Last proof, we learned they were perpendicular because the slopes are negative reciprocals. What did we just learn from doing all these sides here? What do you know about the sides now? Here we go. Drew, what do you know? All congruent. So ADC is congruent to AD. We can just put them all in one full set here. DC, AD, AB, congruent to BC. Because, all right, somebody else, how do we know they're congruent? How do you know from your work above that they're congruent? Ones, Micaiah, how do you know? Well, that's what we're saying. Done. Perfect, because distances are equal. And that's all I need to say, right? 4 congruent sides makes a rhombus. ABCD is a rhombus because, and in your own words, how do you know it's a rhombus? What makes this quad into a rhombus here? How do we know? How do we know? Henry!
All sides are congruent.
Done. That's all I need. If you have a 4-sided figure where all sides are congruent, it's got to be at least a rhombus. Nothing else. Before you move on, the only figure we did not do coordinate proof with is the parallelogram, and I think I'm going to have you do that tonight on your assignment. So if you're asked to prove it's a parallelogram, what would make it a parallelogram? You tell me, because you could go 2 different ways here. What would make it a parallelogram? Look at it one way. So you would use what formula here? Distance. All right, you could do it that way. Well, maybe I don't like distance. Maybe I'm a slope person. So if you're a slope person, how could you prove this a parallelogram if you just wanted to use slope and no distances? Show opposite sides. Parallel. Yep. So you make that decision tonight what you're most comfortable with. Opposite sides parallel slopes or opposite sides congruent distances. All right, good job. That was a little bit.